on your gravitation packet, there is a test review on there. So go ahead and turn to page 12 of the packet. Or 12 of on the back or on the front of page 12, you guys have a test review. So I'd like to review the concepts of circular motion with you guys. All right, now, before you guys finish your lab, because I know some of you are working on the lab, you'll have plenty of time before you guys can turn it in, so don't worry about the lab. Right now, let's just go through our test review. All right, so you have about 20 questions. These questions are extremely similar to what you're going to see tomorrow, right? So just letting you know. Go ahead and take this page out if you don't already have it out. You're not turning it in, but you will be writing a couple of things down. All right, so let's review the last two units, subunits for this gravitational circular motion part. It says gravity is one of how many forces in the universe? There's actually 4 of them, right? So let's go ahead and write that down. Write down 4. It's one of 4 forces in the universe. Right, 2 of them you're learning in physics. One of them is gravity, and the other one is electromagnetic forces, which we'll look at in the spring semester. All right, it says, what 2 factors affect the strength of the force of gravity?
Mass and distance.
It says, yeah, mass and distance. So let's go ahead and record that. Mass and distance affect gravity. All right, now, one of these, and just some advice, because I'm trying to reduce the number of people who miss a couple of these questions. When it comes to mass, they're directly related, so it's a direct relationship with force. When it comes to distance, it's a what relationship?
Inverse.
Inverse, so let's go ahead and document that. All right, so you have direct and you have an inverse. Is gravity short range or is it long range? Long range. What do you think? It's long range. It's very long range. Is it weak or strong? Weak. It never is 0, so it's never 0. Okay, so in other words, it's infinite, right? That's the idea. It's infinite. How long, or how does gravity affect light and time? Remember, we studied this on Friday. It can slow time down, right? It can speed time up, right? So gravity affects light, but how? Einstein figured this out. What was that?
It bends it.
It bends it. Good. So gravity bends light. It also distorts The further away you get from massive objects, the slower time goes for you. And this is proven in GPS systems and satellites. The closer you get to massive objects, the faster time goes. Okay. Who discovered this, by the way? Einstein. Albert Einstein did. And Albert Einstein used what to figure this out? The eclipse, right? So, bends and an eclipse. Einstein discovered this using an eclipse of 1919. Okay, if a massive object and a very low mass object are exerting a gravitational force on another, which one exerts the greater force? So you have one very massive object, you have one not so massive. Which one exerts the greater force on the other? The one that's what? Bigger or the smaller one? Actually, they're equal. It's Newton's third law, which states that what? For every action, equal and opposite reaction. So, go ahead and write that down. It's an equal amount of force. All right, moving on to number 6. All right, if a force acts perpendicular to an object's motion, what happens? What kind of motion do you get? Give you a clue. You get what kind of motion? Circular motion. And it says next, to describe the inverse square law. The inverse square law is the relationship, and for our purpose in physics, and I guess in this unit, would be the relationship between force and distance, figured out by 1 over the factor squared. Remember that? So I wrote it down previously as 1 over x squared. So if you move 2 times away, and this is when I was showing that light to Amanda, right? So if you recall, I had this going on. Get my cell phone light real quick, and I'm going to blind Amanda again. Sorry, Amanda. She's okay. Here, Amanda's. All right, so I have the light here. I'm 1 times away from her. Okay. When I step 2 times the distance away from Amanda, how much light is hitting her eye? 1/4. If I step 3 times the distance away, how much light is now hitting her eye? 1/9, the original. So if I go back in time, back to where I was originally, this is 1 times the light hitting her eye. Now I'm going to get closer to her. I'm going to cut the distance between the light source and Amanda's eye. Ready, Amanda? All right. So now I'm halfway to her eye. She's blinded now, right? Her left eye especially. Now, if I cut the distance in half, by what factor have I changed the relationship here? 4 times as much. It's 1 divided by 1/2 squared. Okay. So 1 divided by 1/2 squared is 4 times. Okay, so remember to work that one out in case you run into it on your sheet. All right, let's move on to the next one. Turn the light on. All right. What would happen to your weight if the Earth was 4 times as massive? So all of a sudden the Earth's mass quadrupled. What would happen to your weight? It would quadruple. It's a direct relationship. So go ahead and note that down. Number 9. Okay, so this is a math question. So let's go up to the front. It says, what is the force of gravity between 2 blocks, each with a mass of 10 kilograms, and they're sitting 2 meters apart? All right, so I know it's asking me for force of gravity. I use my force of gravity formula. It's right here. Force of gravity is equal to big G times m1, m2 divided by the distance squared, where big G is this very small number, 6.67 e to the negative 11. Go ahead and calculate it out. Give you about a minute. Calculate it out. Don't forget to square the distance on the bottom. That's the biggest mistake people make. And let's see what your answer is. So I'll set it up for you up here. should be a very small force because the distance is quite large. All right, check your work. I'll write the answer on the board. And it should be 6.67 e to the negative 9 newtons. Is that what you guys got? Yes. Okay, good. Right. If you did not get this answer, recheck your calculations and make sure you squared the bottom. That's the biggest mistake, like I said earlier. All right. Number 10. What happens to the force of gravity if the distance separating two objects increases by a factor of 3? So if I step away from Amanda 3 times the distance, by what factor does it fall to?
9.
1,
9.
9. Good. So it's 1/9 the force. So number 10 is 1/9. Number 11 says, label the direction of the force acting on the stopper. So for that, I'll scroll down. Right. Let's label all the variables acting on this. What happens?
Okay, on number 9, I got 1.6.
I got 6.67 before you divided by
Yeah.
2 squared.
It should be 1.67 e to the negative 9. All right, so let's make that correct.
That's why I kept checking. I was like, what am I doing wrong?
So that's it, right?
Yeah.
That makes more sense. All right. 1.67 e to the negative 9. Good catch. Let's go over to number 11. Okay, so now let's label all the variables acting on the stopper as it goes around in a circle. Right? So in this case, it's going around this way. It's going around which way is that? Clockwise or
Clockwise.
Clockwise, right? All right, so it's going clockwise. And as it goes up, there's a variable that points upwards. What's that variable? Velocity. Good. V. Velocity. Now there's a force that points somewhere. Which way does that force point?
Centrifugal.
Center. Very good, yeah. So anything with a C means to the center. So F of C means centripetal. Force centripetal. And what about the acceleration?
10.
The acceleration, and there's a C next to it. So that means it's pointing to the center as well. Okay, so A of C goes here. All right. Number 12 says list 3 examples of centripetal forces. Okay. Let's not list 3. Let's list 5. I want 5 centripetal forces. Give me 1. Acceleration is not a force. Gravity is 1. That's 1. So gravity is 1. Give me another one. Tension, good. Friction is a third one, good. Acceleration is not a force. It's a change in velocity. Weight, no, weight is not one. Come on. Spring. Spring, no. Not the ones we study. What about the normal force? And then think about a bird going around in a circle. What does it use? Huh? Air resistance, correct. So jets, planes, they all use air resistance to go in a circle. All right, let's move on to the bottom. Okay. It says define frequency and period. Well, for that, I'll once again refer to the front. Frequency cycles over time, or 1 over the period. And then period is 1 over the frequency, which is time over cycles. So go ahead and note that down. Okay. Let's do a couple of math problems using these formulas. So we're going to practice. And on your test tomorrow, you're going to see the same exact formulas. Okay, you're going to apply them now. It's pretty much straight through. I'll give you a radius. I'll give you the period. You calculate the velocity. And it's very simple, very basic. All right, so let's go ahead and do number 14. It says, if a CD rotates at 10 times every 1.5 seconds, calculate its period and its frequency. So, period, let's do that one first. Period is capital T, and it's time over cycles. All right, so how much time passes here?
1.5.
1.5. Divided by how much cycles? How many cycles?
10.
10, right? So 1.5 divided by 10 is 0.15, and it's seconds. All right, so now to figure out the frequency, what should I do with this period according to the formulas? You do what? So it's asking you for the frequency. So frequency is 1 over the what?
5.
Yeah, so it's 1 over the period. So in this case, it's 1 over 0.15. So do that real fast, and you now have the frequency. Okay, a police light siren rotates 1 time every second. What is its period? So period is time over cycles. So how much time surpasses here? 1 second, right? How many cycles does it do? 1. All right, so 1 divided by 1 is 1 second. The unit for period is the second. If the light siren above is reflected on a wall and travels along the entire 5 meters, 5 meters gives it away that it's a radius. Radius is a distance. How fast is the reflection moving across the wall? Fast. They want to know how fast something is moving. Which one of these formulas is about speed or velocity? V equals what? 2 pi r over t. So velocity is equal to 2 pi r over t. Okay? You're going to use the period from the previous question. So it's 2 times pi times the radius, which is 5, divided by the period, which was 1. So it's basically 2 pi 5. And you should get about 31.42. And it's meters per second. Let's go ahead and write the units down as well. All right, we're almost done. So let's go ahead and do the last couple of problems. All right, number 17. It says, what is the centripetal acceleration of a slingshot that is 1 meter long being swung around at 5 meters per second? So centripetal acceleration, what formula should I use? AFC, right? So AFC is equal to V squared over R. So what's the velocity they provide for you? 5, right? So let's write 5 squared divided by what's your radius? It's always a distance. So it's just 1 meter. So you can do that in your head. It's 25 meters per second squared. Right? Number 18, if the rock in the above slingshot is 0.5 kilograms, what's the centripetal force? They want to know centripetal force. Which formula should I use now? F of C. So let's use F of C is equal to mv squared over r. So my mass is 0.5. The radius is 5 squared. Divide this by the, sorry, that was your velocity. Divided by your radius, which was 1 meter. So it's 0.5 times 5 squared divided by 1. What's the answer here?
12.5.
12.5. All right, so it's 12.5, and it's newtons, because that's the unit for force. 19, we're not looking at, and 20 is, it says, describe the graph that shows the relationship between gravitational force and distance between two masses. All right, so what does an inverse graph look like, if you recall? Very good. It says, here is force and distance, and it should be a graph that looks curved like this. They're technically never touching the line, so it's just an L-shaped graph with a smooth line running from the top, bottom. This shows an inverse relationship between force and distance. Okay, any questions on your test sheet? You guys have anything that I missed or need some other guidance on? Okay, on page 9, I want to say it's 9. I'll go to 9 real fast. You guys have a circular motion question worksheet. Okay? I'd like you guys to work on the circular motion worksheet. It's very straightforward, and you're going to use all your circular motion formulas. Okay? Go ahead and apply that onto your sheet, I'll apply those formulas onto your questions. Answer numbers 1 through 10. Disregard question number 9. So you see where 9 is? Go ahead and disregard question 9. Everything else is fair game. When you're done with page 9, submit it. Okay? If you still need time for your lab from yesterday, go ahead and conclude that as well. I'll be up here and I'll be walking around in case you guys have any questions for me. All right? So go ahead and get started.